In this project, we're going to work with e-commerce sales data that has to be clean. And we do that by creating a data pipeline that transforms the data from raw all the way to business ready using data build tool, DBT. And then we connect this data to Power BI to create a dashboard. This project is a better way to enhance your practical knowledge on DBT and boost your portfolio at the same time. By the way, every single tool that we use in this project are completely free, so you don't have to spend anything on this project. With that being said, let's get right into it. This is the title of the project that we're going to work on in this video, e-commerce analytics, primarily focused on DBT, because obviously this project is a follow-up for our last masterclass on DBT, and I would highly recommend you to watch that masterclass first before proceeding with this project, so you understand what we are actually doing and we do the project in the same pace. Even if you don't have time to watch that masterclass now, you can watch this first and watch that later whenever you want. And I'm going to explain every single thing that I'm going to do in this project in this video itself, so you don't have to watch it, but my explanations I'm going to give in this video are going to be very brief and quick. And this is the whole blueprint that we're going to follow to create this data pipeline. Let's understand this blueprint first, and then we go to the next step. Firstly, our project starts with the data source, which is going to be a .csv file, which has all the data in it. And by the way, we are going to create our or generate our own data source, which is a .csv file using a Python code, and we can customize it, or you can customize it according to your will. Okay, and we are going to ingest some errors as well in that data. Okay, that will be our data source. We're going to create one as a .csv file, and we place that in the seeds folder in DBT, and then we save that data as a table in our database. And after that, we're going to transform the data in 3 stages, which is Medallion storage architecture, bronze, silver, and gold, while the data is in the database using DBT, data build tool. After the data transformation is done and the data is business ready, we connect the data to Power BI to create the dashboard from that business ready data at the end. And that's it. That's our whole blueprint. And these stages, bronze, silver, and gold, if you don't know, if you never heard of it before, I'm going to explain. We basically split these transformations into 3 stages, bronze, silver, and gold. The bronze stage is nothing but the raw data, and the silver stage is the cleaned data. We clean the errors that the data has, like removing the null values or removing the errors like having, let's say, negative pricing or negative amount or quantity. So we take that errors out and we clean the data. And then we do some transformations to make it business ready. You will see what we're going to do. That is basically the Medallion architecture is about. That's our whole blueprint that we're going to follow. Now let's head to the first step of this flow. Firstly, let's talk about the setup that we need to complete this project. We have to install a few things to complete this project, which includes we need Python to be installed on our PC and Docker desktop, Power BI desktop, and we also need PostgreSQL client to connect Power BI to the database. And the installation, I'm going to show you how we have to install it at the time of the connection. Okay, but first, like I said, we need Python installed and we need Docker desktop. I'll leave the link for the download link for the Docker desktop and the PostgreSQL client and also Power BI. You don't need a link for Power BI because that is simple. You can find it in Microsoft Store, or you can just go to any browser and click for Power BI download. There you go. You have a lot of options. Choose the first one and install it. And then same for the Docker desktop, but I will leave the links for that. So let's go with, after you click the link, you'll land on this page. Then you have to hover on this button, download Docker Desktop, and you'll see multiple options. And you have to pick the one that is appropriate for your PC and download that. And when you install it, for all the apps, just go with the default settings and install it. That's it. That's it with the setup. Now, the first thing I have to talk about is Docker Desktop. After installing it, open Docker Desktop. Again, you don't need to sign up or anything. You can just skip the sign up process, and this will be the home page that you will land on. Now, we are going to open two containers. One container for the PostgreSQL database, and the other one for Docker DBT core. The same setup I used or we used in our last video, DBT masterclass. We are going to use the same setup. Okay, I'm going to use the same code, but I'm going to give a brief explanation of what we are actually doing in that Docker containers. Okay, let me now open PowerShell first. Create a folder or our project repository. I'm gonna name it ecom dbt or just ecom. Ecom is fine. So I by this I'm just creating a folder named ecom. So mkdir stands for a make directory. For the people who never use CLI, I'm just explaining the stuff. What we're actually doing here is we're just creating a folder. mkdir stands for make directory, and we're creating the folder with the name e-com, e-commerce, at this location, C drive users and the username. To be clear, here, local disk C, users and the username. Here we're creating this folder. After creating this, I already listed the tools that we need to install to complete this project, yes? But there are a few. There is one more tool that is not mandatory, but it's up to you, which is VS Code editor. So I'm going to open that as well. And I will also leave a link for this download, the download link for this tool as well. This is just a code editor. You can do the same thing with the Notepad as well, but this is more interactive. From here, I'm going to click on that and click on Open Folder and choose the folder that I just created, ecom, right here. Click on Yes. Right now the folder is empty. First folder we have to create is docker compose.yml. Because we have to compose, we have to open those containers. .yml. And for this, I already have a code written. So we're going to use the same code that we used in our masterclass. And I have it saved right here. Now I'm going to copy paste it here. Save it. Now what we're doing here is we're opening two containers. One for, like I said, one for Postgre database and the other one for DBT core, right? Well, we get the image for Postgre from the internet, but this image, DBT core, we will create the image using a Docker file. So we have to create another file named Docker file. Well, you don't have to create them because you can get these files from the GitHub repository link that I'm going to give you in the description that has all the code written already. You just need to copy paste the files at the location and run them. And this is the image. And also, now I'm going to explain what I did here. Like I said, just a quick glimpse of it, just for the people who haven't watched the masterclass yet. What we're doing here is we are creating an image by using Python, and we're installing these two. Where is this? We're installing DBT core and DBT Postgres connectors because we're going to use a Postgres database, and we need a Postgres connector to connect to a Postgres database through DBT core. So we need that connector installed. So we're going to install these two, and these are the versions for both of them. For DBT core, we are going to install 1.11.6, and for DBT Postgres, we are going to use 1.10.0. That's our image, and these are the container configurations. Here we're going to use services, and this is the service name. It can be anything, but we said Postgres just because it is easy for us to identify which container is what. So this container name is going to be Postgres, and the image we're using is Postgres 15. Container name is going to be DBT Postgres. Sorry, this is service name, and this is container name. DBT Postgres is the container name. And then these are the configurations that we can manipulate according to our need. Here for Postgres user, it's going to be the username for our database. Right now it is by default set as dbt underscore user, but we can change it. I'm going to change it to J. And then for Postgres password, I'm going to say password, or say pass@123. And for Postgre database name, the same thing. You can rename this, or you can just leave it as it is. That's fine. You know what? I'm gonna rename it as ecom, or just, yeah, ecom is fine. And then this is the port, the listener. Basically, we use this port to connect to this warehouse. And the volumes and networks. And here for this container, this is a service name, and the container name is dbt core, and the volumes depends on Postgres and networks. That's it. We need these two files saved in our project repository, the root. After saving these files, we have to open PowerShell again. Or you don't even need to use PowerShell. If you have Docker desktop already, what you can do is that's fine. You can do the same thing with the Docker desktop as well by clicking on the terminal option at the bottom right corner here, right here, this one, or you can just do that from PowerShell. Either way, it works. From here, you have to change the directory. Right now, the location is at the C drive, users, and the username, but we have to switch it to our project repository, which is ecom. So we say cd. Cd stands for change directory, and say ecom. Now it is at the root of the repository where our Docker compose file is present, right here. From here, we have to run Docker compose up -d. Well, we run Docker compose. When we run Docker compose up, we are saying we are basically turning up the containers that we are defined in the docker compose.yml file, which are Postgres and DBT core. But here we build our own image, right? Using this file, Docker file. So what we have to do is we have to build those definition first using build at the end, hyphen build. And -d is a flag that we use to detach from the PowerShell, basically. So if we haven't used this one, even after we turn the containers up, we actually see the logs for those containers in this PowerShell or in this CLI. So to avoid that, we detach after we turn the containers up. And that's why we use -d at the end and then run it. This is going to take a few seconds. Well, because I'm running this for the second or third time, it didn't took much longer. But if it is your first time running it, that's gonna take a while. Let's say a minute or two to download all the resources and then turn the containers up. So you have to see these. It says ecom dbt network created, ecom postgres data created, started. So both the containers are started. Now when you open Docker desktop and extend this dropdown, you have to see dbt postgres and dbt core. Now that confirms the database is turned on, that is working, and dbt core as well. But dbt core will stop working after you turn it up for after a few seconds, because this doesn't need to be running all the time. It runs when you use it and turns off again when it is not in use. But whereas in Postgres, because it is a database, it has to be turned on all the time. And like I said, these are the listener ports. Listener port 5432. We have to use that port to connect to the Postgres database. With that, we have our initial setup ready. We have dbt core, so we can run dbt commands, or we can use dbt now. And also we have the database ready, where we have to save the data and transform the data. We have the setup ready. So we head to our first step, which is data source. Now we're going to see how we create the data source, and we learn more about what data we are working with, because we have to know what data we're working with before we proceed with the transformations, right? So we have to do that first. Now, setting up the data source, like I said at the beginning, we are going to use a .py code, a Python code, to create the file, to create the data source file. So what I'm going to do is, I'm going to create a new folder named, let's say, source or data source. To be particular, I'm going to say data source. In this folder, I'm going to create another file and say, wait, I already have the file with me. Don't you worry, I'm not going to copy paste all the transformation files, because these files are the setup that we're going to use. I just going to copy paste these files, but for the transformation part, I'm going to type the code while I explain what I'm doing and what transformations we are actually doing there. So you'll understand what we're up to. Okay, now generate e-commerce underscore data. I'm going to copy that and paste it here. Oh, we cannot do that, I think. Yeah. I have to open that with the notepad. Now copy this. And yes, you'll get this code as well from the GitHub repository. So you don't have to type in or search anywhere else. And for the name, I'm going to say generate sales maybe .py. Paste this code. And before we move further with the process and create the file, we have to know what data we are working with here, right? So we have to know what this code actually going to generate. Before we start, this file, this code, when we run it, it generates a .csv file with 1,000 records in it. And you can change the number of records this code generates by just changing this line alone right here, where it says number of records. You can just change it with something else. So if you think 1,000 records is too much to work with when you're beginning with a project, you can just switch this to 100 or any number you want. But by default, I'm going to give you as 1,000 records, and also error percentage. Like I said, this data should not be this data should not look like a data that we generated, because if we generate the data, that data doesn't have any errors, right? So to make it look real, we are going to ingest some errors into it, and the error percentage here determines how much percentage of the data has errors in it. And right now, by default, I kept 8% of the records will contain errors. So this is the number. If you want 10, you switch it to 0.1010. I mean, yeah, 0.10 as 10. Or for 8, 0.08. That is the number of the percentage of records that will have errors in it. So let's understand the code first. First, we imported all the requirements we need: pandas, numpy, random, faker, datetime. We're going to use faker to generate fake names for the users. Now we're going to create 3 lists. One list for countries. This list has the countries we are going to include in this data, which includes US, UK, India, Denmark, French, Canada, Australia. And then we have categories for the products. So categories for the products. And the list of categories include electronics, clothes, home, books, and sports. And then we have payment methods, which includes credit card, PayPal, UPI, which is India native payment way of payment, and a debit card. So these are the payment methods that the data will have. Now we define a function, this one, named generate data. So whenever we call this function, this will return 1,000 records. Okay. And now in this function, when we call this function begins with creating an empty list named data. And that is why we say data equals empty list. Now we start a for loop for I in range of number of records. And the number of records is 1,000. So this will loop for 1,000 times. For each loop, it creates one record. Order date equals fake dot date between start date, which is minus 1 year, and end date is going to be today. So we're going to use faker to generate a fake date between minus 1 year from today and today. And the quantity equals random.randint of 1, 5. When we say random.randint of, it chooses a random integer in the given range, and the range is 1 to 5. So it picks a random integer from 1 to 5, and that will be assigned to the quantity. And then there comes the price. Price equals round of. First, before going to the round part, we're going to talk about random part. So we use random dot uniform of 10, 500. Just like randint, Random.uniform picks a decimal number. Instead of an integer, it picks a decimal value in the given range. And the range here is 10 to 500. It picks a random decimal value from 10 to 500. And then when it picks a random decimal value, that value has a lot of decimal points. So to avoid that, what we do is we round it up, we round the decimal points to two values. So if the value that is returned is something like, let's say 3 point, no, 11 point, something that long, that will be converted to 11.57, something like that. So we are just rounding up the decimal points to just two values. And then we have data, which is the empty list. Yes, empty list dot append of, and the dictionary. So we append the data. We just combine the data to this list, which is data. Data dot append of, and we append a dictionary every single time. And the dictionary includes the keys, which includes transaction ID, because this data represents sales of an e-commerce website. Every sale is a transaction, and every transaction has a transaction ID. So the first key will be transaction ID. The second one is order date, when the order is placed, and the customer ID, an ID for customer, and the customer name, which will be generated using Faker. And then we use country, and then product ID, the product that is in the order, and the product category, the category that product belongs to, and the quantity he ordered, the quantity of the products, and the price of the product, payment method, and order status. These are going to be the keys of that dictionary. Basically, they are going to be our column headers for our table, the data table. And for transaction ID, because every transaction ID should be unique, what we are going to do is we're going to use f strings, this one, and then we use t as a static string and add I with 1. And the I will be varying from 0 to 999, because we are looping using I here, and it is from 0 to the number of records, which is 999. Well, it is thousands, but it only counts until 999, 0 to 999. And that is why we add I plus 1. So it only has, it starts from 1 to 1000 now. And this is the dynamic part of the string, and this will be added to this static part of the string, which is t. So t, for the first transaction, that will be, the transaction ID will be t1, and for the next one t2, and t3, t4, and it goes on to 1000, t1000. That will be the transaction ID. They will be unique for all the 1000 rows or 1000 records. And for order date, we just say order date, because we already chosen order date here using Faker. We picked a fake date from between the range of an year ago to today. And we have customer ID. We used f strings again to create a dynamic string, and C will be the static part of the string, and the dynamic part is random.randint of 1 to 300. We already know what randint does. It picks a random integer from the given range 1 to 300. So that will be the customer ID. And for customer name, we use Faker to generate a fake name using fake.nameOf. It generates a fake name. And for the country, it chooses random.choice. We talked about random.randint, and we talked about random.uniform of. Now we talk about random.choice of. What random.choice of does is, it picks a random object from a given list. And here we said random.choice of countries. Countries is a list that we already defined with a bunch of countries in it. So it chooses a random one from that list, and that is why we use random.choice of. And for product ID, we use f-strings again, and p is the static part of it, and it uses random.randint of 1 to 200. So it picks a random integer in that range. And for product category, we have random.choice of categories. Again, we already have a list of categories here, defined here. So it picks a random category from that list. And for quantity, we already defined it as random.randint of 1 to 5. And for price, we defined it already as random.uniform of 10 to 500. Payment method, random.choice of payment methods. We already defined a list of payment methods, so it picks a value from that list. And we have order status, random.choice of. We haven't defined a list for that. So we define it here itself inside random.choice of and say completed, cancelled, and return are the three order statuses we are going to define. And it picks a random one for every transaction. And that's it. After that, we have a list. No. Yeah, that's the end of the loop, the for loop. Now, by the end of the loop, we will have a list of dictionaries. In this case, we are going to have a list of 1,000 dictionaries with which represents 1,000 records in the data. And we are going to convert that list of dictionaries into a pandas data frame using df equals pd. Pd stands for pandas, like we know, and assign it to the variable df pandas dot data frame of. So we're going to convert that list of dictionaries into a pandas data frame. Now, after converting that, we are going to call this function ingest underscore errors. What this function does is, we basically define the function right here, but it basically ingests the errors into the data. That's it. After ingesting the data, we're going to talk about the ingest errors function, but for now, let's move ahead with this function first. All right. So after ingesting the errors, what it does is df.toCSV, it converts the data frame into a CSV file named e-commerce underscore sales.csv. And then after saving that as a .csv file, it prints CSV file generated successfully. That's it. Now talking about the function ingest errors. So right here, we are calling this function and passing df, which is our data frame that we created, as a parameter for this function. Now what happens is, in this function we start with num underscore errors and int of length of df. So it sees the length of the df, which is 1,000, length of the data frame, which is 1,000, times error percentage. In this case, we set that as 0.08, which is 8%. So 8% of 1,000 is 80. So now output for this will be 80. So 80 records of that 1,000 records will be errors, and that will be assigned to the number of errors. Now we open another loop, say for underscore in range of number of errors. So it iterates for 80 times in this case. So it iterates for 80 times. Now row equals random.randint of 0 comma length of df minus 1. So because this range starts from 0, we say length of df, which is 1,000 minus 1. So it goes from 0 to 999. So it picks a random integer between 0 to 999, and that will be assigned to the row. Okay, just keep that in mind. We will talk about why we did that later. Now the next step will be error type. So we have a few error types for this data. Random.choice of, so we have a list to pick the error type for every iteration, and it picks one from null customer, so which ingests a null customer value inside the customer ID column, and then negative quantity, which ingests a negative value in the quantity column, invalid price, future date, invalid country, duplicate transaction. Those are the errors. It picks a random error for every iteration, and it ingests that error into a random row, and that is why we defined a variable called random and picked a random value from 0 to 999. Here we start an if condition next and see if error type is equals to null customer. If error type is null customer, because it is random, if it is null customer, what it does is df.at_row at this location, at the row which will be 0 to 999, the row at this location will the customer ID at that location, at the row location, will be replaced with none value, and that is how we ingest null values into our data. And after that, elif error type is negative quantity, we do the same thing, df.at of this location, the column quantity will be replaced with minus random.randint of 1 to 5, so that will be a negative quantity value. And for invalid price, we do the same thing, but here we use negative random.uniform of 1 to 100, so it will be a negative price, which will be an error. And then the next error will be future date. What we do here is we do date time dot now of, so we take the date time, the present date time, and add 30 days to it, so that will be a future date. So a transaction with a future date doesn't make any sense though, so that will be an error as well, because that's a future date. And another elif error type invalid country. So for invalid country, we're just going to ingest a value xyz into the field. And for elif error type equals duplicate transaction, what we're going to do is we're just going to replace a random field with t1, which will be the transaction one, so that will be the duplicate value. And yes, that's it with this function, which ingests the errors into the data. After that, it is converted into a .csv file and saved. That's it. That is the code that we're going to use to generate the .csv file. Hope you got it. Now let's run the file and generate a .csv file from it. So what we're going to do is open PowerShell and type in. Remember when I said the tools that we need includes Python? This is why we need Python. We need Python to run this .py file, which generates the .csv file, and that is why we need Python. So we say Python space generate hyphen sales.py. Wait, so it said no such file or directory, and that is because we saved this .py file under data source and not the root of the repository. But right now here we are at the root of the repository. What we have to do is we have to say cd data source. Now we change the directory to data source, and here we run the same command. Now it says CSV file generated successfully. So when we look at that location, we can actually see the .csv file, e-commerce underscore .csv right here with the data that we defined. The transactions start from T1 to T1000, and the date, customer ID, customer name, which is generated using Faker, and the country, and the product ID, category, and this is quantity, and this, I think this is the price. Well, the 8% error is included in the first record with the negative price, and then we have the payment method and the status. So everything's perfect. We have the data source now. Okay. No, we don't have the data source ready yet. We just have the .csv file, which is going to act as a data source. But we have to place this .csv file under seeds folder and save that the data as a table in our database so we can work on it. So after this, the next step will be initializing DBT. Well, we already installed the DBT using Docker container, but we have to initialize DBT before we work on our project using DBT. So to initialize DBT, what we have to do is we have to open PowerShell, and there is a command to run, which is this one. We have to say docker compose run because our Docker DBT core is running inside Docker. We have to say docker compose. Let me zoom this in a little bit so you will know what I'm typing in here. So we have to run docker compose run dbt init. So we are initializing. Dbt init stands for dbt initialize. So we are going to initialize dbt. When you hit on enter, so that it asks us to enter a name for our project. You can name your project whatever you want. I think I'm going to name it as ecom. Well, let's say dbt ecom. dbt hyphen ecom. That will be the, oh, it's not a valid project name because I think it's because we should not supposed to, the project name should not supposed to have hyphens. It can have underscores as a name. So what we can do is instead of dbt hyphen ecom, we can say dbt underscore ecom. That should be the name, and it asks to enter a number, and the options we have here is only Postgres because we only installed Postgres connector for DBT. So we only can see one option here, which is Postgres. So we say 1, enter, and for the host name, we say Postgres. And for port, the port we used here is 5432. So we use the same port. And the username is J, right? J, and password is pass at 123. Pass at 123. Even if you type the password, you can't see anything. You don't see the dots, so you don't see the password or anything. But it is actually entered because that's password. DBT or CLI doesn't show you what you just put in. So type the password in and hit enter. And it asks for the database name, which is e-com, ecom. Paste that in, and it asks for schema. And for schema, I'm going to say dev underscore schema. We haven't defined the schema yet. I'm defining it right here. So I said dev underscore schema, which stands for development schema. And threads, I'm going to choose 4. And threads determines how many connections we can have at the same time to that database. And I said 4 threads. I mean, not just the connections that are parallelly deployed. Now we have that. After we ran that initialization, we can actually see the DBT underscore project, which is the project name that we picked. DBT underscore project. No, sorry. We picked DBT underscore ecom, right? So yeah, there you go. Under DBT underscore project, we can see DBT underscore ecom. That is the project name that we picked. And here we can actually see all these folders and files created. If you already watched the masterclass, you will already know what all these folders and the files are for, right? First thing we have to do after initialization is, under models, there are a few example models that are pre-created. You have to delete them. We don't need them. Okay, so now the folder is empty. After that, profiles, there you go. In the last masterclass, we actually created this file instead of typing all this stuff at the initialization, right? We created this file by ourselves. Well, this file, by typing in this file, we are not actually setting up the connection. What we are setting up is, we're just setting up the details and the configurations that we need to connect to the database. We are not connecting DBT to the database yet. We just define the connection credentials, or what to say, configurations basically. So when we want to connect to that database, DBT uses these as the what to say, credentials to connect to the database and work with it. Now we have everything ready. We initialized everything. What we have to do is, we have to cut this .csv file from here and paste it under our project, under seeds folder. Okay, now after pasting it, open PowerShell again, and after, we have to run this one, but we have to run this one, docker compose dbt seed. So we have to run dbt seed, but because dbt core is inside docker container, we have to write this whole command, and this is the main part. I don't think you can see it, so I'm going to copy paste it in the PowerShell because this is already zoomed in. So this is the command that we need to use. Docker compose run, the same thing, the same line we used when we initialized dbt. And then we said dbt seed instead of dbt init here. And this is the main command. If we actually install dbt in our local computer without Docker, we only need to run this command. But because we install it in a Docker container, we have to run this whole command every single time whenever we want to run a command. But the main part is dbt seed. Okay, and then the project directory, which is dbt underscore project. That's it. Run. Invalid value, project directory path DBT does not exist. Okay, let me run. And run that here. Wait. Okay. Oh, that is because we, for the project repository, we actually chosen dbt underscore ecom this time. So this doesn't work. Instead, what we have to do is, instead of dbt project here, we have to type in dbt underscore ecom, run it. There you go. Now that will create a table inside our database. Okay. So it says successful loaded seed file dev underscore schema, the schema that we defined or configured, dot e-commerce underscore sales, which will be the table name in under that schema, and inserted 1000 records into the table. To confirm it, we can actually connect to the data warehouse or the database, and we can confirm it ourselves. To connect to the database, what we have to do is we have to use this command, but let me take this down. We don't need this. So, but we can't just use this command right away. There are a few things I have to change, which includes that's correct, which includes the username. This is not our username. I have to use J as the username, and the database name is e-com. That's the database name. This is the command that you have to type in to connect to the data warehouse. All right. So yes, that is the command. It should go like docker execute. Because the database is also in a Docker container, we have to type in this whole command to connect to the database. We have to run docker exec execute and -it and then dbt underscore postgres, which is our container name right here. This is the container name that we defined as, right? And then PSQL, which stands for PostgreSQL, and -u, which will be the username, and the username is J, which we defined here, and the database name should be ecom, because we define it as ecom. So that's the database name. Now, after running that, we are now inside the data warehouse or the database. So what we can actually do is, I'm going to run select asterisk, which is all, select all from the table e-commerce underscore sales. But when we refer to the table, we can't just say the table name. We have to say the schema name followed by the table name using a dot. So the schema name is dev schema. We defined that at the time of initialization, right? Dot e-commerce sales, which is the table name, and end the transaction with semicolon, run it. And there you go. This confirms our data is saved as a table in the database. Okay, that is confirmed. Let me zoom this out so you can see the whole table. Maybe a little more. Okay, that's fine. So yes, we confirm the data is in the database. Now to quit the connection to the database, what we can do is we have to type in backslash and q and enter. That will exit the database connection. That's it. Now we have the data source ready. Now we have the data source completely ready. It is saved as a table in the database. So we're done with our first step, which is the data source. Now let's head to the next step, which is bronze stage. We don't have much work to do here because the at bronze stage the data is still raw, so we just copy paste that data in the bronze stage. That's it. Well, for the bronze stage, we have nothing but copying the data and saving it into a view, right? So we just are going to copy and paste the raw data. To do that, we have to head to this folder, models, and create a new file. Now, create a new folder named bronze just to segregate and separate all the layers, bronze, silver, and gold. So I'm going to name it as bronze. And under this folder, I'm going to create a new file, which will be our bronze transformation, which is basically the raw data with no transformations. And name the file as br, indicating bronze, and e-commerce underscore sales.sql. That's going to be an SQL file because the DBT transformations are nothing but SQL transformations, but what DBT does is it just orchestrates those transformations by creating a DAG graph, directed acyclic graph. For what directed acyclic graph means is, directed means the flow, the graph flows in one direction, and that is what directed means. And acyclic means the graph is not going to be cyclic. It don't loop through the steps again and again. That is what direct acyclic graph means. So that will be created, and then the data be processed, basically orchestrating the data transformation. That is what DBT is. And on top of that, there are these other features like macros, snapshots, and yeah, the other stuff that we talked in the masterclass. So for our first, this one, because we haven't configured any of the transformations in the dbt underscore project. Remember when we worked with this file in the dbt masterclass, we actually changed this file and added few configurations here. So we define the materializations in the folder level. So any transformations that we run in that folder will be created as a view or a table according to what we defined. But here we haven't defined anything, right? For now, only one thing is defined, which came by default, which is example folder that we just deleted. We deleted the example folder, so we don't need this anymore. So I'm going to take this down. But in this project, we're not going to do the configuration at the folder level. What we're going to do is we're going to see how we're going to configure these materializations in the program itself or in the query itself. So to configure that, we have to say double flower brackets and space config materialized equals view. So this output that this .sql file will generate will be saved as a view, and that is how we configure the materialization here. So it will be materialized as a view. Now for the data for this, we're going to select all, everything, all. From, we're going to use ref of because we already have that data inside our database. which is stored as e-commerce underscore sales. Is that the name that we define in the seeds? Yeah, e-commerce underscore sales. That will be the reference. And now save it. Now we have the bronze. Let's run this first and see if it works. And then we write the silver and then run those transformations as well. So what we have to do is we just run dbt run. So we just, this dbt seed, but we need to run dbt run or dbt compile. I'm going to run dbt run. Dbt run, paste it here, run it. There you go. Invalid value project directory. Oh, I forgot to edit the project directory again. The project directory should be dbt underscore ecom. Now copy paste it. Yep. Says okay, created SQL view model dev schema dot br underscore e-commerce underscore sales, and that with that we're done with our first transformation layer in the Medallion architecture, which is bronze. Now we head to the silver layer where we clean the data. Okay, to do that, under models we're going to create a new folder. Like I said, we're going to name it as silver because that will represent the silver transformations, and create a new file. But before typing in the silver transformation code, we ourselves ingested the errors. Yes, those includes like 6 types of errors, but we have to make sure those errors are actually in the data that we just saved in the database, right? So let's make sure the data is in the errors are actually in the data that we ingested. To check that, we have to connect to the database, right? So let's connect to that. You know what? I'm going to open a new PowerShell window, a separate one which has connection to the warehouse, and the other one for the DBT operations. Okay. Now this one, I will use this CLI, this tab for warehouse and the other one for DBT. So let's connect to the warehouse. Here, let's type in our first query. But to check our first error that we ingested, which includes, where is our code? Data source, generate sales, right here. So the first error is null customers, which ingests the null values in the customer ID column. So to check that, let's say select all from dev underscore schema, which is our schema name, dot e-commerce sales underscore sales, and say where customer ID is null, space, and limit the output to 10 records because we can't see all the errors, right? Because that's too long. So I'm going to limit the output to 10 records. Run it. There you go. The first one we checked is, oh, the customer ID with null values. Okay, there you go. So all these records has the customer ID as null. There is no value in that column. So that is checked. And for our next error, we have negative quantity. So to check that, we say, and also, well, this prints the raw columns where the customer ID is null, right? To actually see the count, what we can do is we can just add count of asterisk. So we say count of asterisk, and that's it. This will print the count of the rows that has null as customer ID. There are 13 rows with null customer ID. That's good. Now for the next query, we say select asterisk. The same thing again from dev schema e-commerce sales. Say where quantity is less than 0 and limit that to 10. Run it. And yep, there you go. These are the columns, these are the rows with quantity as negative value. All of them have negative values. And to see count, like I said, we have to just type in count of asterisk, and this will print the number of columns or number of rows with that value. There are 9 rows with negative quantity value. And the next error that we ingested is invalid price. To check that invalid price, the price, I think it's the same. Well, it's the same query for this as well, just like the quantity, but we just use price here instead of quantity. That's it. Because we only ingested negative price as the invalid price. So here, let me zoom that in. I copied the wrong line. Okay. Have to copy this one and just replace quantity with price. Run it. There you go. These are the rows with price as negative. There you go. So it has -6, -1, -35. So that's correct. Moving on, we have in the number of rows. Forgot about that. Copy paste. But here we have to type in count of 13 rows with negative price. The next one is future date. So let's check that. So we use the same line up to here. Paste it. And then say where cast of, because the order date right now we haven't converted that into these values into integer. Right now it is saved as a string, so we have to cast it into integers, or no, not the integer, by the way, date. We have to cast it into date before we work with it. So we cast order underscore date as date, close it, is greater than is greater than current date, and of course limited to 10 rows. Enter, and the date. So today's date is March 5th of March. So, and these rows have 4th of March, and yeah, they're all 4th of March. So these are all future dates which are invalid or which are errors. Now let's see the count of those rows. So to print the count of rows, we just say count at the beginning, just like the other ones. Count of, and run that. We have 20 rows with invalid dates or the future dates. And the next error, we have invalid country, which is, so the country is XYZ. We're not going to search for XYZ, the countries that says XYZ, the rows that says country as XYZ. Instead, what we're going to do is, we're going to check if the country names are in this list. If there is, if those that particular row doesn't have a country from that list, that will be printed as an error row. We're going to use the same thing up to here to where and say country not in, and start the list, copy paste this. This is our list. So it checks if the country is in this list. If not, that will be printed. And limit to 10 rows. Enter. Well, we did got an error. Says does not exist. Okay. So the problem here is we can't use double quotes in SQL. So we're just going to edit this part of the query and replace those with single quotes. There you go. Now we have it. Paste it, run it. Okay, so there you go. So all these rows has the country as XYZ, which is not in the given list. Okay, that is confirmed. And the number, to check the number of rows, we say count of, right? And paste this query again. Run it. We have 13 rows with invalid country name. And what else we have? I think we have one more error, which is duplicate transaction. So to find the duplicate transaction with a query, this is going to be quite different than the rest, because we are actually finding the duplicate transaction IDs. So select transaction ID, comma, count of all. We're going to see how many of them have the duplicate IDs. No, not how many. I'm going to talk about that later. First, let me write this query. And then the table is dev schema e-commerce sales. And then we use group by. transaction underscore ID and having count of all is greater than 1. So we are grouping the transaction IDs and checking how many of the rows have the transaction, how many of the transaction IDs have the count more than 1, which basically says which transaction ID has duplicates and how many duplicates does it have. Enter. We did got an error. What is it? Syntax error near transaction ID. Okay, the error is at the group by, I said group underscore by. It should just be group by, no underscore. Just gonna take that underscore out. Now run it. And there you go. There's only one transaction that has duplicates, that is T1, transaction ID T1, with 13 duplicates. With that, we have all our errors ingested into the data, and we confirmed it. Now let's head to the silver stage. Create a new file with the name sl underscore e-commerce sales.sql. This is going to be quite of a big query because this is the main cleaning transformation stage. Okay, first we need to materialize it. So we are going to configure it, saying config parenthesis and materialized equals table and a space here. Now we are going to materialize this output as a table, but before, for the bronze, we materialized it as a view because, well, that is just a raw data stage. But if we create a table for that raw data stage, it doesn't make sense because we already have a table of the raw data saved using seeds, right? Right here, this one. We already have a raw table that is saved. So when we create a view, what a view does is it doesn't actually store the data again. It only stores the logic, and the logic points to the source table, which will be the table that is named e-commerce sales. Yeah, e-commerce sales. So it just points to that. Whereas when we create a table, it stores the data again in that physical location. And that is the difference between a table and a view, if you don't know. We already talked about these differentiation as well in the masterclass, but I'm just going to remind you again about the difference. So, but here we're going to use table. We're going to create a table to save the data again because we don't have, yeah. Because to make those queries run faster, we're going to create a table here. The transformation starts with creating multiple CTE, common table extensions. So the first CTE named as cleaned, say select transaction ID, comma. We're not going to deduplicate yet for the transaction ID. We'll do it later, okay? And also cast order date, because the date will be saved as string in the table. We have to cast it into date format. Say date as order date, comma. customer underscore ID customer underscore name. Then we open a case. There you go. When country in I'm going to copy this. So it checks if the country is in this list. Just that. Then country. So if the country name is in that list, don't change anything, just assign country to country. Or else if it is not, say unknown. The country name, whatever is at that spot, will be replaced with unknown. So XYZs, all the XYZs in the country column will be replaced with unknown as value. And as country. So that will be from the, by this we deal with this error, the invalid country name error, okay? But we haven't deal with the customer ID or transaction ID or the order date yet, but we will. So first we deal with country. Now say product ID. We don't have any errors for product ID yet, right? Nothing for product ID. Yep. So that will stay as is, and say product category. No errors for product category as well. Yep. And now for quantity, we're going to open or use another case when quantity is greater than 0, then quantity else as 1. So all the negative quantities will be replaced with 1. And as quantity. That's our next column. And moving on, we have dealt with the negative quantity and what else? The country, invalid country. We have 4 other errors left to deal with. First, we're going to deal with the price because it's the same logic as quantity, so we're going to deal with that. Another case when, but this time for price. When price is greater than 0, then price else 0. End as price. And for the next column, we have order status. From, I haven't used capitals for any of this. Well, Well, it doesn't matter in SQL, but it makes it more readable when we use capitals for certain words. But I forgot. That's fine. And then we use ref from the bronze view, which is br underscore e-commerce underscore sales, because that will be the bronze view name, right? The name of the bronze view that we created in the bronze layer stage right here. So whatever we name this transformation whatever we name this file of the transformation will be the name of that view or a table that will be created from this transformation. So in that case, here whatever the data or the output that we get from this query will be created as a table. So it will create a table, and the name of the table will be sl underscore e-commerce underscore sales. So that's the reference, and now we say where customer ID is not null, and just like that, we will filter out the customer ID, the null values in the customer ID. That's it. And now for the order date, we're going to use first we're going to say and cast order date as date now is less than or equal to current date. So these will be filtered out. So what are the errors that we dealt with? Now we dealt with customer ID, right? And we dealt with negative quantity and negative price as well, the invalid price as well, and the future date as well, and the country. Now there is only one thing that we have to deal with, which is duplicate transactions. Okay, for that, we're going to create another CTE, say deduplicated as parenthesis, and say select asterisk comma and a new new column, say row number of over partition there should be a parenthesis here when we partition it. Partition by transaction ID and order by order date DESC. Here we don't have to cast the order date again as a date because it is already casted in this CTE, this table, and we are going to call this table into this CTE, so we don't have to cast it again because it is already casted here. Say as RN. So we are going to assign row number by partitioning. So we are assigning row number by partitioning transaction ID, right? Transaction ID and ordering that by order date. So that goes from, so the transaction which is happened latest will come on top because it is in descending order. The latest date will come at the top. The transaction with the latest date will come at the top, and the rest will be it follows accordingly. As it goes down, the order date goes what? Goes down, gets older. Okay, and we partition it by transaction ID. And because we partitioned everything by transaction ID, this row number and the order by will apply for each unique transaction ID separately. So if there is any duplicates in the transaction ID, which we do have for transaction ID T1, all those transactions will be ordered in the descending order, and will be applied a row number for each of them, starting from 1, and and then we filter the latest one out next. So to filter the latest one out, what we are going to do is say from cleaned, which is our CTE that we created before. Now from this, we use select again, select all from deduplicated, where rn equals 1, which is the row number that we assign for every unique transaction ID. So it only picks the transaction ID. It removes all the duplicate values, all the records with the duplicate transaction ID, and only picks the latest transaction that is recently happened, because we ordered it by order date, remember? So that's how the logic works. Rn, and that's it. Well, this is a pretty big transformation, but yeah, we're done with all the errors now. Now let's run DBT and see if there is any errors in this transformation. Let me copy this command, paste it here, run it. So we do have an error, and the error is at, well, it says the error is at this location deduplicated at, but the actual error is, well, it is at that location because we defined two CTEs, right? We have to separate them with a comma, and I forgot that. That's the error. So here, before we define another CTE, we have to separate those CTEs with a comma. Now let's run that again. This should fix the error. There you go. And because we filtered out the duplicates, it says it selected only 955 records out of 1000, because the other 45 are filtered out because of the errors that we that are taken out in the transformation. Now we are done with the silver, which is cleaning stage, which means in our new data we shouldn't have any of these errors. So I'm going to check with just one error, because I don't want to waste our time by checking all the 6 errors again. So I'm going to check one error and see if it is fixed. For that, I'm going to check the duplicate transaction ID. Maybe 2 errors. We'll check 2 errors. And our new table is, the new table that we created is SL underscore e-commerce underscore sales. Copy that, paste it. There you go. It says 0 rows now. So that is fixed. And one more, let's see one more thing, which is country, invalid country name. Let's try that. And our table name is SL e-commerce underscore sales. Run it. Oh, it still says 13 because we haven't removed those rows, but we replaced those fields or those values with unknown. So it still says the count as 13. But let's actually print the rows and see. There you go. All the invalid countries are replaced with the string unknown. And yes, we're done with the transformation, the cleaning stage. Now let's head to the goal stage. Make the data business ready. This one. For our last transformation stage, I'm going to implement a star schema. If you don't know what star schema is, I'm going to give you a basic brief introduction of star schema. Okay, we're just going to separate this data. Instead of storing everything in one single table, what we're going to do is we're going to separate entities of this data. Let's say, for example, here in this case, we're going to divide the customer details into one table and call it customer dimension table, and then one table separately for order details and call it orders dimension table, and another table, say fact table, which combines these two tables together. So when you picturize it, it basically looks like this. So there is a fact table, and there are multiple dimension tables created for each of the entity of data. Let's say customer, one for orders, and one for shipment. So these are all the dimension tables, and all these dimension tables are connected together with one fact table. One fact table. So these are all connected to one fact table. That is how star schema works. And when you picturize it, it basically looks like a star, and that is why it is called as star schema. We're going to implement that. We're going to create two dimension tables and a fact table that combines these two dimension tables together. For that, let's create a new folder named gold. And for our first transformation, we're going to create the dimension table for customers and name it dim, which means dimension underscore customer.sql. And we are going to materialize it as a table too. Config materialized equals as table, space here. Now select distinct. You know what, I'm just going to use lowercase for everything instead of using uppercase in the middle. I'm keep forgetting to use uppercase, so I'm just going to go with the lowercase for everything. Select distinct, say customer, and for the readability, I'm going to write these queries in new lines. We can actually write the whole query in one single line and it still works. Because SQL works on transactions. So when you put a semicolon, and that is when the transaction ends, or else it just goes on. It doesn't care about the new lines or stuff like that, like Python. So we can write the whole query in just one single line with just spaces alone. Customer name and country as well. And for the reference, I'm going to use the silver table, SL, e-commerce, sales. Perfect. That's it. We have our first dimension table. Let me close these. And let's create a new file for the next dimension table for orders. No, not the orders. Orders will be the fact table. We're going to create a dimension table for products. That's a separate entity of data. So name it dimension product .sql. And for the query, we are going to materialize it as table as well. Okay. Select distinct of. I think I haven't talked about distinct. It only picks the distinct values. I mean, the unique ones and not the repeated ones. Product. Category. So this table only has product ID and product category because it is only focused on product data. So from reference of the same reference, which is the silver table, and a space here. Save it. That's it. Now let's create a new file for fact data. fct underscore. Now we say orders, because orders is the one we combine the both dimension tables together. The same configuration, we're going to create a table, materialize it as a table, and then select transaction ID, customer ID, product ID, order date, quantity, price, and quantity times price as total amount. We haven't have this column from the beginning. We don't have a total amount column, which we multiply quantity to the price of the product. So if you buy, let's say if you have a smartphone that is worth $100 and the quantity is 2, so the order has quantity as 2 and the product as a smartphone, which is with price $100. We have to multiply quantity times price to get the total amount for that particular transaction. So that is what we calculated here, the total amount. Say order status from the same reference, which is the silver data. Save it. Now we have all the transformations ready for the goal. We have one for dimension customers and one for dimension product and the other one for fact orders table. Star Schema. Now let's run the command dbt run again. Let's see if we get any errors. Or yeah, there you go. We did got an error at dimension customer, and the error is I spelled customer name wrong. CUT. I spelled it as CUT where it is CUST. Right here. CUST. Okay, let's run that again. Just in case, to debug, we can just see the output here. Okay, it shows which model is actually failed. Right here it says the bronze one is successful when you see the green and it says create. So the green indicates it is successful and red indicates there is an error. And orange indicates a warning. Okay, so the bronze one is successful, it is green, and silver is successful, it is green, right? Silver. And the first dimension dime customer has an error and it is red, says error. That is how we find which model is triggering the error. Okay, where we are. Okay, so that is the model that is failed or triggering the error, and the rest of the models, dev schema fact order is successful, it is green, and dev schema dimension product is also successful, it is green as well. And to see the actual error to debug, here is where we can see it. Say failure in model, it also says which model failed. Failure in model dimension customer, and it actually says which line is has the failure at. Right here it says customer name does not exist. This is the error. Right here, when you read this line and take a close look, you can actually find the error here itself. It says CUTOMER underscore name does not exist, where it is spelled wrong, and that is how we find what the error is. Right. This is where we see the actual error and debug it. That's it. We got all the outputs ready. Now, with that, we're done with our third stage in the data transformation, which is the goal stage. Now, the only step that is left in our plan or the data pipeline is connecting this output business ready data, the dimension and the fact table, to Power BI. Let's head to that. Well, to connect Power BI to our database, we need to install, like I said, we need to install PostgreSQL client. We actually need that client to actually run an SQL database in our computer, but because we use Docker to containerize everything, we haven't done it before. But now, to actually connect to Postgres database from Power BI, we need to install PostgreSQL client in our PC. And I will give you the link, and this is the link that I'm going to give you. When you click on that link, this will be the page that you will be landing on. You have to click download the installer, and choose which preference, choose whichever link you want according to your system configurations. Mine is Windows, so if you're Windows, click on this button and this will download the file. That will be of 344 megabytes in size, so that will be downloaded, and click on that file. That starts the installations. Everything, you leave everything default, all the settings. You don't have to change anything. Right after the installation is done, it also has to install another thing. I'm not sure what that is, but you can skip that part. You just need to install the client alone. You don't need to install anything else. So you need to install that. Now open Power BI. After installing Power BI, you have to open that. From here, we have to connect to our database. get data from other data sources. Search for Postgres. Right here it says PostgreSQL database. Click on it. Click on connect. Now for this, for server, the actual server name is local. The server port is localhost, and the colon should be 5432, which is our port. So we have to use this port 5432 that we configured when we open this container. Because it is running in our local host, we say localhost colon 5432. That is our server. And for database, the database we defined in Docker Compose is this, which is ecom, e hyphen com. That will be our database name. And yes, click on OK. Okay. Now click on database here. For the credentials, click on database here, and for the user, this will be the username that you configured when you open the container. This will be the username and the password that you configured here in the Docker Compose file. So mine is Jay for the username, and password is PASS@123, and hit connect. It says encryption support. We are unable to connect to data source, whatever. Click on OK. When you click on OK, now you can actually see all the tables and the views that are in the database. Now we don't need all the data, all the tables that are here. We only need the gold layer tables, which include the dimension customer, dimension product, and fact order. These three are the tables that we need. Choose those three tables and click on load. And like that, we have all the tables that we need in the gold layer right here in Power BI. We can actually connect these tables together in the Power BI when you click on model view, and from here, because this is a star schema, we can actually connect these things together by so this should be connected to this using customer ID, right? I think we just have to drag and like that. So the customer ID is connected with this one, and the relation should be many to many. Is that correct? Or one to many? Should be one to many. Okay, let it be many to many then. Many to many, save it. So that is connected. The same thing with the product ID in the dimension product and the fact orders product ID. And this relation should be many to many again. Okay, save that. Now we connected all the three tables. Let's go to the report view again. Here, these three tables are now connected. We have all the data here. I'm going to create a few charts and show you how we can actually create these charts, and it depends on you how good you design the dashboard and add it to your project. But the data engineering part is done. Now this part is about data analyst maybe creating the dashboard. So yes, that is up to you. You can make it look more fancy, or you can add more charts and make it look more informatic. It's up to you. Okay, for our first chart, let's create let's choose country and customer ID. Okay, this will create what? A map chart. Okay, now what we're going to do is we're going to drag this customer ID. I can zoom it in. Okay, I'm going to drag this customer ID into the bubble size. So now the bubble size is dependent on the count of customer IDs from that particular location. So we can see from which location which location have more customers and which has less customers. We can compare the location wise customer count. So, and these are the bubble sizes. We can do that. So when you hover on these bubbles, you can see how many customers are actually in that location. Here we have, in Canada we have 141, in US we have 145, and in India we have 120, Australia has 136. That's one idea to create a chat. And what else do we have? We can actually create a KPI card. No, not for this one. A separate KPI card for the total sales made. And the total sales made is $705,000. That is the total sales made. So we have to click on the KPI card. We clicked on the KPI card and chosen the total amount, which is the total amount for every transaction. And when we sum everything up, there's the total that we got. And that is the total amount of sales that is done in these 1,000 transactions. We've done $705,000 in sales. Yep. That's it. In that way, you can actually create a whole dashboard with all the parameters that we have. Actually, we have a lot of them. We can at least create 7 charts from these data and create a dashboard from it. You can design it in your own way. With that, we're done with the final step as well, connecting the goal layer data with Power BI dashboard. Now let's have a recap of what we actually done. First, we created our own data source, which is a .csv file we created using a Python code, which has 1,000 records. And then we stored that data in the bronze stage with no changes at all, just as is. And then we cleaned the data by removing all the errors that we ingested, because we want to mock the data to be as a real data in the real world. So we ingested the errors and we solved it, we cleaned it in the silver stage and saved it in that stage. And then we made the data business ready and saved it in the bronze stage. Later, oh, and by the way, we saved the data in Star Schema in the gold stage. And later, this Star Schema formatted data is connected to Power BI. And after connecting to the Power BI, we connected the tables inside the Power BI, all the 3 tables, and we created a dashboard. That's the whole flow. With that, we're officially done with this whole project. Yes, if you like the video, don't forget to subscribe and share to your friends who actually want to do a project on DBT. And yeah, I just want to make this project so simple, and that is why it is kind of faster than the other projects that we have worked on. And yes, I will be back with another video. Probably I'm planning a project that is complex, not simple like this one, a complex project which includes a lot of tools, maybe 4 to 5 tools that we done master classes till now, and do a big project. I'm planning a big project for the next week. I'll be back with that video. Until then, adios.